This is Amanda Martinez, and this is my reassessment on Newton's second law. So the question I did was a block of mass M1 equals 2.6 kilograms, and it rests on an inclined board that is angled at theta above the horizontal. A cord connects the mass M1 with another mass M2, which equals 2.2 kilograms over a frictionless pulley. M2 is 2 meters from the ground. When released from rest, M2 strikes the ground after 2.0 seconds. Find the angle made by the board with the horizontal. So after I read the problem and looked at it, I wrote down all the information that they give you in the problem. And they give you the masses of the two blocks, they give you the distance from M2 from the ground, and they give you the time it takes for M2 to hit the ground after it's released. And you can assume that the initial velocity is 0 meters per second because it says when released from rest. So then I drew my free body diagram so I could show all the forces acting on each block. And on M1 you have mg going down, tension going up, normal force going up that way, and no forces this way. And then for M2 you have tension going up, and then you have mg going down. So then I redefined my x and y axes so I could get the components of mg, and for mg I got the x component as mg sine theta, and for the y component as mg cosine theta. And so since the bodies are moving, we know that we have to use F net equals ma because they're not at rest. If they're at rest, we would use F net equals 0, but they're moving. So in order to find your equations, you have to know that t is moving up in the positive direction and mg sine theta is moving in the negative for mass 1, and mass 1 is moving in the x direction, so that's why you're only using the x components, not normal force and mg cosine theta. So since you use these two, you get t, since it's in the positive, minus mg sine theta equals mass 1 times a. And then for mass 2, you get, since t is moving in the up direction, in the positive direction, it's negative. And then since mg is moving in the negative direction, it's positive. So you get mg minus t equals m2a. And then once you get these two equations, you look at them and you see that you have two unknowns, these t's, and in order to get rid of them, you have to add them together. So I added these two equations together and canceled the t's out, which gives you m2g minus mg sine theta equals a m1 plus m2. So after that, I looked at this equation and I saw that I have values for m, I have a value for g, I have a value for this m, and I have a value for g. I don't have theta, I don't have a value for a, which is acceleration, and I don't have I do have mass 1 and mass 2. So then I come down here and solve for a, because in order to get theta, we need to know a. And I decided to use this equation this formula, because it has time, and you know that they give you the time in the problem, and also they give you the distance in the problem, and it has final distance. So you have every value you need to solve for a. So I set it up and solved for a and got a equals 1 meter per second squared. Then after I got a, I went back to my first formula that I got from adding these two together, which was m2g minus mg sine theta equals a m1 plus m2. So now I have every value for each variable except for theta. So in order to find theta, I plug in all my values, and then I solve for theta, and you have to do sine inverse of this answer, 0.658, and you get theta equals 41 degrees.